In this video, we're going to look at application of forces. So in this particular problem, a horizontal force is being applied to a particle. So let's take a past exam question. A parcel of weight 10 newtons. So what I'm going to do, I'm going to redraw the diagram on this side. So we've got a nice diagram to resolve forces on. So we have an inclined plane. We know that the angle to the horizontal is 30 degrees. We have a particle like so. We've been told that the weight of the particle is 10 newtons. So let's drop the weight coming down. And we have a horizontal force acting on the particle like so, and that is P newtons. So a horizontal force of magnitude P newtons acts on the particle as shown in figure 2. The particle is in equilibrium and on the point of slipping up the plane. So it's on the verge of moving. So it's not actually moving, but it's on the point of moving. We call that limiting equilibrium, or at this point equilibrium. The normal reaction of the plane on the parcel is 18 newtons. So let's draw that in. So it's 18 newtons. And the coefficient of friction between the parcel and the plane is mu. So if the particle is trying to move up, that means that the frictional force is trying to move down. So I'm going to draw that here. And that's going to be denoted by mu r, because friction is mu r. So now what we can do, we can start resolving the forces. So we treat the weight as the hypotenuse of a right angle triangle. Don't forget you must have arrows when you resolve. So this is 30 degrees. The force that contains the angle is cosine, so that's going to be 10 cos 30. And then the one without the angle is sine, so we get 10 sine 30. So now what we're going to do is say, right, well, I can see two parallel lines. So I've got a parallel line here, so it forms a nice alternate angle. So now we can resolve this force by saying we have P cos 30 and P sine 30. So now that we've resolved all of our forces, we can now start resolving perpendicular and parallel to the plane. Resolving perpendicular to the plane, so if we look perpendicular to the plane, what's happening? So we've got 18 and the force that's opposite is 10 cos 30, and we've also got P sine 30. So it's going to be 18 minus P sine 30 minus 10 cos 30, and that's equal to 0 because it's not moving perpendicular to the plane. So we could rearrange for P sine 30 to give me 18 minus 10 cos 30, and therefore P is 18 minus 10 cos 30 over sine 30. So we can now get our calculator and type that in. So we've got 18 minus 10 cos 30 over sine 30, which is 18.7. Correct the three significant figures. Newtons. So if you want to store that value onto your calculator, press store and A, and it stores it in the value of A. We may need that value for future calculations. So now we're going to be resolving parallel to the plane. So we can say what's happening parallel to the plane. So we've got P cos 30, because don't forget the particle's moving up the plane. So it's P cos 30. We need to minus 10 sine 30. Minus the frictional force, which is mu r. Don't forget r is 18 in our case. So this is simply 18 mu. So it's going to be minus 18 mu. But don't forget it's not moving, it's in limiting equilibrium. So it's equal to 0. So we can solve for 18 mu equals P cos 30 minus 10 sine 30. So we can say that's 18 mu is 18.67 and so on times cos 30. Well, 10 sine 30 is 5, so I'll put minus 5 here. And now we can say mu is 18.67 times cos 30 minus 5, all divided by 18. So we can now use our calculator for this. So we know what 18.67 is. We get that by pressing alpha and A as our stored value, times cos 30 minus 5 divided by 18. And that will give me 0.621 to three significant figures. I'm also going to store that into memory. So if we go, so now for part C, the horizontal force is now removed. Determine whether or not the particle or the parcel moves. So now we need to draw a new diagram for part C. So for part C here, let's draw a new diagram. So incline to the horizontal 30 degrees. We've got our particle. We've got our weight, 10 newtons. So now the horizontal force has been removed. The particle is trying to slip down. Therefore, frictional force is opposing motion. So it's going up. So it's going to be 0.620 times by whatever r is. So we've got r. And now we're in a position to resolve. So we resolve as we always do, treating the weight as the hypotenuse of a right angle triangle. Don't forget you must always have arrows when you resolve forces like this. So you got 10 cos 30, 10 sine 30. So for this part of the question, we have to now work out r. So we can say resolving perpendicular to the plane. We're going to get r minus 10 cos 30 equals 0. So we can say r equals 10 cos 30. But friction is equal to mu r. Now we worked out mu from before, 0.620. Times that by what we got for r, 10 cos 30. So we can work that out on our calculator. So I'm going to get 5.38 newtons. Correct, the three significant figures. So the force in the other direction coming down is 10 sine 30. But that's 5. So because the frictional force is greater than the force coming down, the friction is stopping it from trying to move. So we will have 5.38 is greater than 5. Therefore, the parcel does not slide down. The plane. Here's a question for you to try. You can pause the video and when you're done, I will go through my work solution. Okay, welcome back. So in this question, we've got the weight acting down, which is 1.1 g. The normal reaction, because the particle's touching the plane, is r. And it's trying to slip down the slope. Direction of motion. So frictional force is opposing motion, so 0.5 r is acting this way. Now we can resolve. So this is alpha, so this will be 1.1 g cos alpha because it contains the angle. The one without the angle is sine, so 1.1 g sine alpha. So we can now resolve this force. We have an alternate angle here. So we got P sine alpha, P cos alpha. So now we're going to draw a triangle. So we can draw our right angle in here. This is alpha. Tan alpha is 3/4. So by Pythagoras, this is 5. Sine alpha, 3/5. Cos alpha, 4/5. So now we're going to resolve perpendicular to the plane. So resolving perpendicular to the plane. So we're going to have r minus 1.1 g cos alpha. So 1.1 g. Now we know that cos alpha is 4/5. Minus the other force coming down, which is P sine alpha. So that's P times 3/5. and it's not moving in the perpendicular sense, so it's equal to 0. So we can say that R minus, I like to leave my answer in terms of G, so it's 1.1 times 4/5, which is 22G over 25, minus 3P over 5 equals 0. So R is 3P over 5 plus 22G over 25. So we can now resolve parallel to the plane. So we're going to say resolving parallel to the plane. So when you resolve parallel to the plane, it's trying to go down the plane. So the force coming down is 1.1 G sine alpha. So it's going to be 1.1 G sine alpha is 3/5 minus the other force going up, which is P cos alpha. So cos alpha is 4/5, so that's minus 4/5 of P minus the other force going up, which is 0.5 times R. So in our case, that's going to be 1/2 times 3P over 5 plus 22G over 25. So it's in limiting equilibrium, so we're going to make this equal to 0. So we can say 1.1 times 3/5 is 33 over 50 minus 4P over 5 minus 3P over 10 minus 22G over 50 equals to 0. So we can solve for this by saying that 4P over 5 plus 3P over 10 is equal to 33G over 50 minus 22G over 50. So that will give me 8P over 10 plus 3P over 10 is equal to 11G over 50. So now we can get 11P over 10 equals 11G over 50. So that will give me P is 11G over 50 divided by 11 over 10. So that will give me 11G over 50 times 10 over 11. So we cross these out, get 1 and 1, cross these out, get 1 and 5. So we get G over 5. So we're going to do 9.8 divided by 5. Which is 1.96 newtons. So we can plug this in to find R. So R is 3P over 5. Plus 22G over 25. Type that straight into our calculator. 3 over 5 times 1.96 plus 22 times 9.8 over 25, and that will give me 9.8 newtons.